Good morning, everybody. Welcome. This is Scott Rainovich. I'm the Event Director with Infonetics Research, and we have another in a series of our live webinars this morning. Today we're going to be looking at session border controllers in VoLTE. This is a live webinar for mobile network operators, and it's sponsored by Metaswitch. We thank them for sponsoring this webinar. We will also have our own research on this presentation. So let me tell you a little bit about today's speakers. Today we have Martin Taylor. He's the CTO of Metaswitch. And we have Diane Myers, our principal analyst in the VoIP, UC, and IMS area. And again, I'm Scott Rainovich, and I will be moderating the presentation. At the end, we will take your questions. Please use the Q&A application at the bottom of your screen and send me questions, and I will try to get them to our speakers. With that, I'm going to pass it on to Diane Myers, who's going to tell us a little bit about Infonetics research and what's going on in SBCs and VoLTE. Diane?
Thanks, Scott. Let me just give you a little background if you aren't familiar with me. Here at Infonetics, I cover all of the voice over IP technologies, things around IMS, things to do with consumers and businesses. This topic around voice over LTE and the infrastructure challenges and opportunities is absolutely one that we have been looking at and spending time studying over the last couple of years. I'm going to take a few minutes and I'm going to talk about our overall market dynamics that's happening for mobile operators and then also what we see in terms of voice over LTE. And then I'm going to pass it over to Martin. But before I get started, I really want to thank everyone for joining the call. I took a quick look, and we have people on this call from around the world, from the Americas and Europe and Middle East, and I saw some folks from India and different parts of Asia. So I just want to extend a really warm welcome to everybody, and I appreciate your time today. And we have lots of good information, and Martin's going to present lots of really insightful data also. So let's get going. Let me advance the slides. So when we look at the mobile industry, right, the mobile operators, right now, broadband rules, right, this is what is driving traffic on the networks, but it is also what is driving revenues. It's driving investments in terms of what's happening here. Okay, but it's also under pressure, right? The mobile operators, there's lots of competition for enhanced services, what we consider to be kind of the over-the-top and free types of services. So the pressure is around becoming, more than just a dumb pipe, right? Or maybe a smart pipe is actually a better term for that. Voice. Let me just set the stage also because we are going to talk about voice, so that while broadband rules and it is really driving a lot of activity for the operators, voice still remains 40% of mobile service revenue on a worldwide basis. And that's important, and I really want to set that because we do hear a lot about free and voice going away. And voice minutes are declining. I'm not gonna lie about that, right? And people are communicating in many different ways, not just voice, but it is still a very significant portion of revenue for operators on a worldwide basis, so it cannot just be ignored. Right? We don't expect operators just to let it go, so to speak. Okay, so I want to set that because that's an important part, right, when we consider about what is the future of voice for the mobile operators. We are, right, we think about, broadband, right, and going back to my comments at the top, and we think about LTE, right, LTE, and this is the topic of this, this is the underlining theme for this webinar, but in general, right, LTE is probably one of the most important or the hottest topics around what is happening in the LTE space. But when we look at what our forecast is for 2012 on the mobile broadband subscribers, LTE, right, it represents less than 5%. So I put that out there because we are still very early stages. Right, the primary focus is on the data, right, on the broadband side. But I don't want people start putting up the red flags, and we hear a lot of alarms, right, that voice over LTE hasn't started yet, or it's only in small pockets. And I'm going to get to a lot of that. But in terms of what we look at in terms of just the broadband side, it is still very early stages. We are still in the infancy of this, okay? So it's a marathon, not a sprint, and we need to keep that under the context of this. So let me just talk on a couple of points, and then I'm gonna move on and talk more about the voice over LTE. But just to hit on a few things, right? When we think about what's happening, right, with the data, and I did talk about that, right? Mobile broadband is driving the activity from the operators, right? And so a couple things that they're looking at, and I hear this. I actually had some conversations recently with a number of mobile operators in terms of what they were going to do with voice and what they were going to do with voice over LTE. And their number one thing that kept coming back to me is we need to keep our costs in line with the expected revenues. Yes, VoIP may be 40%, but it is being pressured. It is under strain. So if we're going to invest in new infrastructure, we need to make sure it's in line with what we expect our revenues, right? We need to look for efficiencies in our network, right? We need to do things better, smarter than we've done before. And that leads us to talk about things around new licensing models and network virtualization. And that's going to be a theme that becomes very apparent throughout the coming slides. So what is the near-term situation, right? What are some of the challenges? And I think this sets up what, in terms of voice and even messaging, right? The adoption, there is a large adoption of over-the-top mobile VoIP. A lot of that today is not just VoIP. Let me just set the stage that when we think about these providers, we think about the Skypes of the world or maybe the Googles here in North America. The interfaces, right, they're bringing together very enhanced services. They're bringing together the messaging. They're bringing together the voice, the presence, maybe some video capabilities. And all of that is creating a much richer experience, right? And so it's not just competing with free or very low-cost services, but it's really competing with kind of enhanced capabilities. And most mobile operators that I've talked to over the last 18 to 24 months, they understand this, right? So when they're going forward and they're thinking about what they do when they go to all LTE, all IP networks, and what they have to do with voice over LTE, is really trying to understand, do we have the infrastructure to run enhanced services, not just the voice? Okay, and that's important, and that's what a lot of them are thinking about. How do we compete against them, right? We don't want the business to go over there. We want to be more than just a smart pipe. We want to provide a really rich experience, okay? Today, we do have a few operators, right? We talked about the LTE on the data side being less than 5% of all subscribers. Well, it even lags even greater for voice over LTE because we're very early stages. And in 2012, we saw Metro PCS and we saw some of the South Korean operators go live with commercial voice over LTE services, right? We expect further activity here in the U.S. with Verizon Wireless. AT&T isn't listed here, but we would include AT&T. We include Sprint going into, as we exit 2013 and we go into 2014, right? So we actually do a study every year, one of my colleagues, who looks at LTE deployment strategies, right? And he actually surveys service providers, mobile operators worldwide. And one of the questions we've asked actually over the last couple of years of doing this study is around the time frames, right? When do you expect to launch voice over LTE? And you can see some of the options here, right? At launch, 1 year after launch, and so forth. And I just want to highlight that it isn't, the majority of the operators are not deploying voice over LTE at the launch of LTE, right? When they launch their data, it's all about launching the data first. And so that's really what this, what that graphic shows you. So what are they doing, right? What's happening? Well, they are using circuit switched fallback, right? They're using dual radios, right? Those are interim solutions that most of the operators are using or plan to use, right? But on the flip side, we see a lot more devices that are supporting SIP, and we know that IP is beginning to proliferate, right? So that is going to be a pull and a draw. And then we also see that Wi-Fi is becoming an alternative access, right? And it's happening more and more. I know that there are, especially as I go and I travel throughout Europe, I see, right, more and more individuals are getting a data plan. They may be on prepaid voice, And often what they're doing is they're using those over-the-top applications when they're connecting to the Wi-Fi network. That could be voice, that could be messaging, it could be video, right? And we're seeing that, particularly in the environments that are heavily on the prepaid side. So it's setting up some interesting dynamics that individuals, right? We know smartphones are proliferating. Smartphones are going through the roof in a number of countries, right? It's not just the U.S. It's throughout the world. We have the Android devices, we have the Apple iPhones, we have the tablets, right? And people are, consumers are savvy. They're looking at what are alternatives, right? How do I limit the amount that I'm spending? And Wi-Fi in most countries, especially in the Western world, is pretty prolific, right? I can find a Wi-Fi network fairly easy, traveling. So this is our roadmap. So this segues into our discussion around what we expect for voice over LTE. And this is a slide that we really have not changed significantly over the last few years. Okay, we talk about where are we now, right? We're towards this kind of this first. We're in the end of the first wave, right, which is all around early LTE and LTE rollouts. And we've had a number of VoLTE trials, right? We've had people testing the architecture, doing some trials. We keep hearing of more trials happening, particularly in new countries and new regions throughout Europe. We have the early launches. Right, we have SK Telecom, we have Metro PCS. We know that we have trials that have gone on with Verizon Wireless. We know AT&T is going to do some pockets of trials and some small commercial launches this year. And then we start moving into 2014, and we see some more actual commercial launches, right? But they will be islands. And that's kind of a key, right? It goes back to my point that I really made on that first slide, which says that this is still early stages, right? We're still not widespread even with LTE and on the broadband side. So we expect to see the islands. We expect to see that happening with the alternatives, right, with the dual radio, with the circuit switch fallback. And then we start seeing more full coverage. And we expect that coverage to not really happen, right, until the 2018-2020 timeframe, when we start seeing more and more where we can do a lot of roaming. We can do that. And that's important. And so why do I show this? Because I think we're in this stage, right? We're in this 2013 to 2015 that a lot, while it's not, while we're still in this island phase, there's a lot of planning going on. We know there are a lot of RFPs. We know there's a lot of vendor trials happening. So while they may be small pockets and small islands, now is the time that operators are thinking about the architecture, right? What does that look like for them? What are the applications they're going to do? And so this is the key. This is the time that learning is going on and decisions are being made. Okay, so this is, so we're in that time frame, and that's important. Right? So do we expect in 2014 to have this widespread coverage? No, but it's still leading up to where we're going to have to go. Nothing happens in fast motion, right? So taking on, and I'm going to wrap up here, and then I'm going to turn it over to Martin in a few minutes. But as you can see, this is our forecast. If you look at the yellow bars, this is what we expect in terms of voice over LTE subscribers. We're small, right? We did have some launches in 2012, but we move beyond the islands. We still have islands, but the islands grow bigger, and we start getting more widespread, especially in larger countries like the U.S. By the time we hit 2016, then we start seeing it more broadly adopted within certain countries. But we're still, if you look back at that road, if you think back to that roadmap slide I still have, we're not at full LTE coverage yet, and so we're definitely not at full voice over LTE, but we start to really accelerate. Okay, and that's what's important. That we see that jump, we start planning for it now, and things start to really scale, right, on a much larger basis, right? Not throughout different areas. So hopefully I've set this up, and I'm going to turn it over to Martin, and he's going to start digging into. Let me advance the slide here for a second, into some more details about what this means to you for your infrastructure and your architecture. So Martin, I'm handing it over to you.
Thanks, Diane. So we've been involved with session border control technology and products for about 6 or 7 years now. And of course, the majority of the work we've been doing in this space has been in the fixed line area. But I think everyone recognizes that voice over LTE is, where the really big shift from TDM technologies to voice over IP is coming. This is the big one, if you like, and that's simply because there's just such an enormous number of mobile endpoints that ultimately will be moving from a TDM-based voice environment to an IP-based voice environment, and we call that voice over LTE, of course. And so what I want to start off by doing is sharing with you the insights that we've gained in talking to mobile network operators and thinking hard about the requirements for session border control in voice over LTE applications and how they differ from the requirements that have traditionally applied to SBCs, mainly in the fixed line space. And this first slide really addresses the question of scale. These are numbers, the first two columns, which are the number of IMS endpoints in the fixed and mobile space out there. These are numbers that come from Infonetics. And the number on the right, which is the total install base of mobile phones in the world today, estimated at the end of calendar 12. And you can see a huge disparity here. So the transition of mobile voice from the circuit switch world to the IP world has only made the very, very first baby steps. And it's worth remembering that this transition that's started to happen, 140 million fixed IMS endpoints. Obviously, there are also a number of voice over IP fixed endpoints, which are not IMS, pre-IMS, if you like. But that has been driving the session border controller market up till now. And what we're seeing with this, potentially enormous total addressable market, and it may take 15 years for all of these endpoints to transition to voice over LTE, but network operators should be under no illusion than that eventually all voice is going to be carried over IP, and that's the transition that they have to plan for. So number one challenge is simply the enormous scale on which this transition is going to take place over. The second challenge has to do with the amount of load that voice over LTE places on the control plane of the IMS network. And there are a number of different factors here. When we talk about dimensioning session border controllers in the sort of traditional fixed line market, there's a sort of rule of thumb that most people tend to use here, which is when you think about the signaling load related to the subscriber population or the number of busy hour call attempts, you tend to use the metric, well, it's roughly 7 SIP messages per call. That's actually the minimum number of SIP messages that you can use to set up a call. That's the setup and teardown. So that rule of thumb is very often used to dimension the signaling capacity that you need out of your session border controllers. But that rule of thumb really falls down very badly when we start trying to apply it to voice over LTE for a whole number of reasons, which I enumerate here. First one is that the call setup and teardown, the SIP flows that are mandated by the 3GPP standards and the GSMA IR92 standard requires an average of 14 SIP messages per voice call. And the reason that's a lot higher than the most basic kind of call setup is that the standards mandate, first of all, that you use reliable provisional responses, and secondarily that you also have to use a thing called preconditions. And preconditions is all about extra SIP messages that verify that the voice bearer has been properly established across the LTE network before the call can proceed. So that's what's responsible for this roughly doubling of SIP message load just for voice calls. The next factor is that in a voice over LTE network, of course, you also need to support SMS. And in voice over LTE, the SMS messages travel over via the SIP signaling plane. Every time you send an SMS message, it goes out in one SIP message and you get an acknowledgement coming back. And it's worth remembering, of course, very much depending on which country you're in, but if we take an average around the world, it's not unusual to think in terms of 5 or 6 SMS messages per call. So talking about an average user sending 5 or 6 times as many SMS messages as they make voice calls. So the point here is that the signaling load arising from SMS is very comparable to the signaling load arising from the setup and teardown of voice calls. The next point has to do with something that voice over LTE SBCs have to do that typically doesn't apply in the fixed space, and that is interacting with policy and charging functions. And these are 2 distinct functions. So there is a diameter message flow to the policy and charging rules function that essentially opens up a gate allowing media flows in the voice over LTE network. And then there is a diameter message flow to the charging collection function, which is essentially there to create call detail records so that call can be billed. So that's 8 additional messages that the SBC has to handle. And then finally, there are some event subscriptions, some SIP event subscriptions that are, again, mandatory according to the IR92 spec. The endpoint has to subscribe to the reg event, which essentially tells it whether it's still registered in the network or not. And it also has to subscribe to the message summary event to support message waiting indication. And when you add those up across a typical voice user profile, then typically what you're finding is that it's roughly 4 times as many SIP messages per call on average required in voice over LTE networks as compared with basic fixed line voice over IP. So the rule of thumb metric that we've been used to using, now we have to multiply that by 4 in order to get a sense of how much capacity we need in the signaling plane of SBCs to support voice over LTE. Okay, so the third challenge I'm going to talk about really has to do with the functional requirements for SBCs in voice over LTE networks and how they differ in terms of what are the key requirements here from traditional SBC environments. Now, obviously, there are many aspects of session border controller function which are common and remain the same, and they include things like providing security for the network and detecting and blocking distributed denial of service attacks and that kind of thing. But from a sort of compare and contrast standpoint, I think I would point to some very key differences here. When a network operator is selecting a session border controller for a traditional network in the fixed line space, there's a tremendous focus on SIP interoperability. I mean, one of the most important things session border controllers do there is they mediate between the many numerous different flavors of SIP that are implemented in SIP business phones, in IADs, in IPPBXs, and the flavor of SIP that is actually talked by the service provider's network. And what you look for from an SBC there is a very broad range of interoperability with different kinds of endpoints, and the ability to manipulate the contents of SIP messages in order to work out any differences that may exist between endpoint SIP implementations and what's supported in the core network. When we look at the voice over LTE environment, we're looking at a very different space. I mean, we're looking at a space where the SIP behaviors are very tightly specified by the 3GPP specs. So we're no longer concerned about fixing up SIP messages to deal with interop issues. We're concerned with a very strict compliance with a hugely complex set of specifications that are laid down by the 3GPP. The second thing, of course, and I've already alluded to this, is we're looking for massive scalability. We've got a lot of endpoints that we need to transition to voice over IP ultimately, and those endpoints are averaging 28 messages per call, as we've just seen from the previous chart. So scalability and performance, particularly in the signaling plane, is going to be crucial here. And then the third thing is, as we talk to mobile operators about their plans for building out their voice over LTE networks, and this is very much a trend that's emerged over the last 6 to 9 months, I'd say. Almost universally, they're saying, we want functions like session border control to be built out in a virtualized software-only environment rather than deploying proprietary fixed function network elements in the traditional way. It's been remarkable how rapidly this this trend has happened, and this sort of change of sentiment about how networks are built. And I want to say just a few more words about this, because I think this is really absolutely crucial. There was an initiative launched in October 2012 by a group of 13 major network operators. They published a white paper. It was actually presented at a software-defined networking conference. The white paper essentially is kind of, in a nutshell, what it says is, it talks about network functions virtualization. And the idea here is that instead of deploying network functions, and we're talking about routers, we're talking about deep packet inspection devices, we're talking about firewalls, we're talking about session border controllers, the whole of the IMS core, all those kinds of functions. Instead of deploying those as individual boxes that have a fixed function, that typically the box and its software are supplied by a particular vendor, they don't want to do that anymore. They want to purchase those functions as software appliances that can be deployed on top of generic standard industry standard servers connected by generic industry standard Ethernet switching infrastructures and served by generic industry standard storage. And they expect that to be mediated by a virtualization environment, so that you can lay down a big pool of computing resources and deploy these software appliances in a virtualized form, so that they make the best use of the underlying processing power of that hardware. And there are a whole range of motivations described for this move. A lot of it has to do with cost reduction, of course, but it also has to do with things like speed of innovation. I mean, there's an expectation that if you can essentially define your network functions by plug-in software appliances running over what looks essentially like a data center infrastructure, then your velocity of innovation can be much higher, because you're not talking about approving a physical piece of hardware and then physically deploying it in the network. Of course, you have to go through the testing on a piece of software, and you have to approve that for deployment in the network, but the barriers to that are seen as lower. And the barriers to entry for innovative new providers of network function capabilities are also lower, because you don't have to design and build a specialized piece of hardware to house that network function. In the white paper, session border controllers were specifically identified as one of the network functions that this group expects to see virtualized in due course. Now, this initiative has been gathering momentum tremendously quickly. There has been a decision to convene an industry specifications group under the auspices of ETSI. This is meeting every 3 months, and the activity is expected to last for a couple of years. This isn't a standards-making body. This is a body comprised of network operators and interested vendors who are coming together to identify the challenges of realizing network functions virtualization, and then setting out to drive the industry to address those challenges and make that happen. Now, before I move on and ask the question, okay, so how does this apply specifically to session border controllers? I just wanted to ask Diane if she could comment on what she's seeing and hearing about this whole network functions virtualization initiative.
Yeah, thanks, Martin. And this is just very broadly around the IMS equipment and the SBCs. Absolutely, a lot of the conversations I'm having with mobile operators around the world, this is a topic that keeps coming up, and the reasons are, Martin alluded to cost savings, but even above and beyond that, one of the things that is reiterated a number of times from different people is that they're looking for better efficiencies, right? They're looking for better ways to utilize the capacity they have. So yes, there is cost reduction, but it's around flexibility and just building better efficiencies, because they know that going forward, these networks are going to have to scale, right? And not just scale for subscribers, but scale for the amount of traffic that's happening. So this is a topic that is top of mind for, I would say, almost all mobile operators as they're looking to move forward. So whether or not they all do it, but it's definitely a topic that they're looking at and evaluating, absolutely.
And if I can just add our experience to that, I mean, we in the last 6 months have not had a single conversation with a significant mobile operator where they have not said, there's a lot of negatives in that sentence, I'm afraid, but every conversation we've had essentially has been, look, we do not want to build networks anymore the traditional way. So, if we're talking to you about session border controllers, we're talking to you because we believe that, or you're telling us that we can deploy them in virtualized form, because we're not going to deploy this type of network function in a traditional form anymore. So, I mean, very black and white, quite extraordinary. Okay, so let's just talk specifically about the challenges of virtualizing session border controllers. And just a factual observation here that today's SBCs, with one exception which I'll come to, are full of proprietary hardware. And there's a good reason for this. SBCs do a number of jobs that people have traditionally expected that you need to build proprietary hardware to do. And in this picture, which is a very sort of crude high-level diagram of what a session border controller looks like inside, I've identified at least 4 things that we see session border controller vendors typically relying on their hardware to take care of. We start at the bottom right. This first function has to do with protecting the signaling plane from denial of service attacks and other kinds of malicious activity. The general purpose CPU typically will detect malicious behavior, but it will then program the network processor to discard incoming packets from blacklisted IP addresses. Obviously, network processors are very good at doing this kind of thing and can handle those incoming packets at a very high rate. The other functions typically are associated with the media plane. So 3 specific things here. I mean, one is, in most cases, media is flowing through a session border controller, very often in support of NAT traversal, where we have to actually map IP addresses in RTP packet headers and police the flows. So imagine you've got thousands of incoming RTP streams. Every incoming RTP packet, you have to look up the flow descriptor that is associated with that particular flow, and then handle the packet according to what that flow descriptor says. And typically, the solution for doing this is, again, to use a piece of hardware called a ternary content addressable memory, because it can do a very fast lookup based on the contents of the packet header. Secondly, session border controllers, if there is secure media involved, and in the case of VoLTE, the expectation is that network operators will support access to VoLTE services over Wi-Fi, but in doing so, they will mandate secure RTP, because otherwise the speech is in the clear, and there's no security protecting it. So there's an expectation that at least a substantial proportion of calls in a VoLTE network will come into the network over secure RTP and then need to be interworked with RTP. In other words, the encryption-decryption has to take place. Session border controller will typically do that and will typically make use of some sort of crypto accelerator hardware to achieve performance and scale in that function. And then thirdly, a lot of people expect that the session border controller in a VoLTE network will perform transcoding on at least some proportion of calls. So let's imagine that you've got a converged network where you've got hosted business voice with SIP desktop phones that support high-definition voice using G722, and then you've got VoLTE endpoints which are required to use AMR wideband as their high-definition voice codec. If you want to interwork those, then you're going to need to transcode somewhere in the network. And in some cases, the access session border controller is where you do it, or the interconnect if it's between different networks. And again, typically you expect to bring digital signal processors into the path, and again, session border controllers typically do that in order to achieve performance and scale of transcoding. Okay, so having said this, okay, all this hardware is there for a good reason. How are we going to address the question of virtualizing this thing? Is it even remotely feasible? So that's what we'll tackle next. New approaches to building SBCs that make that possible. So the somewhat surprising and counterintuitive point here is that it is possible to kind of address two of these requirements that we've talked about, the scale requirement and the virtualization requirement, by building session border controllers purely in software. I mean, it's an obvious prerequisite. If you want to virtualize a session border controller, then clearly it has to be implemented purely in software. It's got to be able to run on a completely generic standard x86 server environment. But the surprising thing is that actually you can achieve massive scalability by doing the same thing, especially in the signaling plane, which is what we're most worried about because of the problems of scale that I already talked about. So let's examine why that is possible, because as I say, it doesn't feel at all intuitive. And you might say, well, if this was so, why is it that the session border controller vendors went out and designed a piece of hardware? Because that's a lot of work. And really, this is come about because of huge improvements in the Intel architecture that have taken place really over the last 5 years. I think Intel started to realize that the whole field of communications computing was a potentially interesting market for them. I mean, just as the market for desktops and laptops, started to be negatively impacted by people using tablets and other kinds of devices for accessing the internet. So they've been looking around for other areas that they can play, and I think they very smartly anticipated this whole network functions virtualization movement some years ago. So what we've seen in the last 2 or 3 generations of Intel CPUs is massive improvements particularly in packet processing capabilities. The addition of a lot of extra hardware acceleration functions that are absolutely relevant to what we're trying to do here with session border controller, particularly for cryptographic kinds of functions. And we also see a lot of cache memory. Now, the great thing about cache memory is you can access it extraordinarily fast. And in fact, if you've got the right sort of software algorithms, you can access cache just as quickly as you can access a memory entry in a TCAM. So they're very comparable in terms of memory speed and capabilities here. Now, it's not a no-brainer to build a scalable SBC on standard hardware leveraging this stuff. It does require a lot of smarts in the software area, particularly in 2 areas. One is parallelizing your process across multiple cores, because one of the characteristics of these CPUs is you get a lot of cores for your money. I mean, you can already buy single boxes that have got 32 cores in, running 2 hyperthreads per core. If your software can be parallelized to run across those cores, take advantage of it, then you can leverage the power. Not all software is architected that way. And then the second thing is you need to be able to handle packets at a very low level very efficiently. Remember what I said about throwing away packets from blacklisted IP addresses. Typically, people think you need a network processor to do that. Well, you don't if you are prepared to write the very low-level software, at the level of kernel modules in Linux that do that throwing away for you before you ever get anywhere near the rest of the IP stack. That requires a good deal of extra knowledge and skill. Okay, now I want to talk about another aspect of SBC architecture here, which is distributing the signaling and media functions. And I mean, there have been lots and lots of debates and arguments about this over the years, so I don't want to dwell too long on this. It is well worthwhile maximizing the scale of your signaling function, because that's where all of the complex configuration resides. The fewer instances of session border control signaling function you have in the network, the fewer separate boxes, logical boxes, you're actually trying to manage and configure here. The other benefit of distributing the architecture here, and I'm talking about separation of signaling and media functions in software, is that you really don't actually know necessarily ahead of time exactly how much processing power you're going to need to throw at the media plane. There's a lot of variability here in terms of how much transcoding you're going to need to do, what proportion of your calls are going to need SRTP to RTP interworking, and increasingly we're seeing the deployment of technologies in SIP networks that provide for NAT traversal without the need for relaying media through a session border controller. And I'm talking about stun and turn and ice. Now, it's in the interest of network operators to encourage the deployment of those technologies because it costs money to relay media in the network. And, as Diane said, we want to try and engineer cost out of the network. So minimizing media relay is really well worthwhile. If you buy integrated session border controllers that have got a whole bunch of media capabilities in them, and then you find that they're being grossly underutilized, then that is a poor use of capital. Okay. Let's move on now and talk about the sort of general feasibility of SBC virtualization. Our view here certainly is that all of the functions of an SBC that we've talked about can be virtualized. We've proven that in a number of different kinds of hypervisor environments, KVM, VMware, even on Amazon Web Services. We've seen excellent signaling performance. Media performance I would describe at the moment as acceptable. It's cost effective, but it could get a lot better. If you take the same piece of software, run it on bare metal, and compare it with running it over a hypervisor for doing the media functions, then what you find is that the hypervisor is a significant bottleneck on media flows. But we are expecting, this is a challenge that the industry has absolutely recognized. It's come up as already in discussion in the Network Functions Virtualization Working Group, and we expect to see the hypervisor vendors address this. Transcoding is one function that is unquestionably somewhat more costly than with a DSP. So if you just compare raw costs of hardware, DSPs certainly win. But when you compare and contrast these two solutions based on all of the other factors, the operational savings of running everything in a virtualized environment almost certainly trump any hardware savings you get from that very specific comparison of DSP-based versus software-based transcoding. Obviously, that's a set of sums that's a bit of math that every network operator has to do for themselves. But our view certainly is that while DSPs win in terms of a very narrow comparison, you must remember that when you deploy DSPs in the network for transcoding, that's all they're going to do. If you deploy a general purpose CPU in the network, and some of the time it's doing transcoding, the rest of the time it can be doing something else. And that makes a big difference to the overall economics. Okay, so let's just now drill down a bit on Metaswitch's solution in this space. A product we call the Perimeta Session Border Controller. I think we bill it as the first scalable carrier class SBC entirely in software. From a functional standpoint, it has the VoLTE access functions in it, as well as those needed for doing IMS interconnection. We've been at the last two VoLTE interop events organized by the Multi-Service Forum and very successfully participated in those tests. We are now able to supply this as a pure software solution to run on bare metal, and that's a supported option. We will also provide lab support for virtualization. We haven't fully released that yet. The reason being that we haven't fully tuned the software to run in all kinds of virtualization environments. But any network operator that comes to us, and we've done this several times already, and says, look, here's the virtualization environment I want to run my network on. Can you get Perimeta up and running in that environment so I can test it? And we can absolutely do that, and we've done that several times already. And I've talked about scalability as being important. On current hardware, about 250,000 concurrent signaling sessions per server. But remember that with Intel standard hardware, each new generation is getting more and more powerful. So roughly every 15 to 18 months, we're seeing a new generation of CPUs hitting the market. And every time that happens, you're going to see an uptick in terms of our ability to handle messages per second or concurrent signaling sessions or whatever metric you're talking about in terms of performance and capacity. Okay, so just to briefly conclude, and then I'm going to hand back to Diane for any concluding remarks she wants to make. So I hope I've conveyed the point that from an SBC point of view, the criteria that apply to the selection of products to fill the SBC role in a voice over LTE network is very different. Those criteria are very different from those that have traditionally applied in fixed line voice over IP. So just because you may have a relationship with an existing vendor in the fixed line VoIP space, and they may well have done a great job of addressing that need, does not mean that they are necessarily the best product available on the market to address the needs of voice over LTE, particularly if you're looking towards a virtualized environment. And in our view, this fundamentally changes everything. We are talking about an end to proprietary hardware for most network functions. Obviously, there are functions like optical transport, which are going to require specialized hardware. But any function that has IP interfaces that can be hooked into the network physically as Ethernet, and that is software-centric in the future, and I'm talking about the very near future, those functions will be delivered and installed and deployed in the network as pure software. And what we're saying here is that we think that as network operators evaluate and select products to deploy in their voice over LTE networks, when they're looking at the session border controller, please take these criteria into account. Diane, over to you.
Thanks, Martin. Yeah, I'll let you catch your breath, and I'll just say some concluding remarks, and then we'll get into questions. Probably the number one question I get around this topic, and I think it's worth addressing here towards the end, is, and I touched on it a little bit at the beginning, which was, will operators actually do voice over LTE, or does the world go completely to kind of over the top? And whether that over top be from, kind of a third party kind of company, or, from the operators themselves. And I think, what we see is that the large, right? The large operators, and even beyond the large operators, while voice is declining in terms of usage and it's being pressured by revenues, it's still important, right? People still expect to be able to make traditional phone calls, and that does not go away over the next, at least the next 10 years. And as the networks move to all IP, they have to be able to address that, and that will be voice over LTE. Okay, so in terms of evaluating the opportunity and looking at what happens with the infrastructure components, including the session border controllers, yes, this is an opportunity. Voice over LTE will be real, but there's so many alarms that it's not happening today. And I just want to alleviate people. Technology doesn't move at lightning speed, right? We are still in very early stages. Operators will have to do something in the network with the infrastructure. That does not mean that there will not be activity that happens, right? That operators don't do software-based voice, application-based voice. But even underlining that, there will still be requirements for certain levels of infrastructure. It's not just applications. You still need to be able to have secure networks. You still need to be able to route that traffic around. And in that situation, session border controllers still play an important role. And I think that's just important to understand, right, in terms of what happens with wireless voice over the next 10, 15 years. There were some good questions that came in, and let me, I may be cutting in on Scott. I don't know if Scott wanted to say anything, but if Scott doesn't mind, I'm going to at least kick it off with at least one question that I saw as I was looking at them coming in as Martin was speaking. I think, Martin, this is one for you to answer, and I'm going to ask you. And the question was, will the NFV include supplementary features like transcoding, TLS, etc.?
Okay, so I mean the NFV in general, I mean obviously it's a very broad initiative, but its objective is to get into a virtualized environment as many network functions as it possibly can. So when they talk about virtualizing a session border controller, I mean there's a very clear assumption that yes, they're talking about everything that a session border controller does. So if a session border controller terminates huge numbers, hundreds of thousands of TLS sessions, then absolutely, yes. Then if it's going to work in a virtualized environment, it absolutely needs to operate on a comparable scale, terminating those TLS sessions. And it's certainly capable of achieving that kind of scale because, primarily because of the work that Intel have done in providing the hardware support. I mean, we take the particular case of TLS. Remember that a lot of websites are handling huge numbers of incoming TLS sessions for secure web browsing. That's why Intel put those crypto acceleration instructions in their CPUs. We can leverage those. We do leverage those in scaling up our support for TLS in a pure software SBC, and that absolutely works in a virtualized environment.
Great. I have one other question that okay, Scott, I'll catch my breath. Scott, I'll let you talk.
Well, that's all right. If you have another question, go ahead and ask it. This is for Martin.
Yeah, the question came in that I thought also would be that I'll ask Martin because I think this is best for him. It said, what kind of media scale have you seen in a virtualized environment, and likewise for software-based transcoding? I think this is probably more in a test environment, Martin, but I don't know if you can share what you've seen for scaling the media side. Yep.
Sure. There are clearly challenges in terms of media throughput with hypervisors right now. It's not a bandwidth challenge because actually, people have demonstrated the component that causes the bottleneck here we're talking about is what's called the V-switch. It's the piece of software that presents virtual NIC appearances to the software appliances sitting on top of the hypervisor and the physical NICs. In terms of bandwidth, there's plenty of bandwidth there. The issue is packet handling overhead. And just to give you a sense here, with a very modest standard off-the-shelf server, and I'm talking about a $5,000 box, we're easily able to do 30 to 40,000 concurrent media sessions. You introduce the hypervisor, and it's a heck of a lot less than that. You probably less than 10,000 sessions. So it's a significant hit, but the hit exists simply because up till now it simply hasn't been a priority for the hypervisor providers to focus on very small packet throughput. The V-switch component is being optimized for sort of general purpose networking, and never anticipated huge numbers of RTP packets coming in, with maybe only a complete packet size of 100 bytes or so. So there's no fundamental limitation here. This is simply a case of, fine, okay, if this is something that hypervisors and their V-switches need to do, then we'll just tune the software so it does it better. It's not something that Metaswitch is currently tackling. We could probably make a contribution here, but to give you an example here, Intel has a technology called DPDK, the Data Plane Development Kit, which is all about optimizing the data plane on Intel CPUs, and I believe that they are working together with Open vSwitch, which is one of the open source activities in the hypervisor space, on addressing this particular issue. So this is an issue that will apply to any device that we want to virtualize that's going to sit in the media plane. It applies not just to SBCs but also to media resource functions, for example, because that's another function that the NFV expect to show up in the hypervisor. So we don't have any concerns about the ability of virtualized SBCs to handle media. Right now, this very instant, there are some quite severe limitations in media throughput. But even so, the hardware cost per media session is not in our view completely out of whack. You could go ahead and deploy a reasonably economical solution today based on a virtualized SBC, but clearly we expect that over the course of the next 12 to 18 months to get much better. Again, as far as transcoding is concerned, there's no question that, and I don't think anyone would want to argue with this, that you take the very best DSPs on the market, and you compare them with Intel CPUs, it's probably as much as an order of magnitude in favor of the DSPs as far as physical density is concerned. As far as hardware cost is concerned, it might be of the order of 2 to 1. But as I say, you got to remember the cost of ownership of an investment in DSPs that are being used purely for transcoding against the investment in CPU, general purpose CPU power that you're using for transcoding at one instant, and then later on the same day or the same minute you're using it for something else. Plus, of course, the operational flexibilities. I mean, one of the cost savings people expect to come out of NFV is the ability to essentially build the network by means of point and click. You need an additional SBC for capacity. You literally, through a GUI, instantiate that SBC, and through the GUI, hook it into the underlying virtual network infrastructure, and it's done. The savings that accrue from that almost certainly trump any savings that you might get by insisting that your transcoding is done in a dedicated DSP farm.
Excellent. Thank you, Martin. We have a few more minutes to take a couple more questions. Let me cover quickly some housekeeping items. However, we have a lot of questions about on-demand and slides. Just for your information, this presentation will be available on demand and archived 90 days after this webinar. That will be active approximately 4 hours after this webinar closes, and you can access that by using the same link and registration page that you would use to get the live webinar. So again, for those of you out there who might want to pass this on to colleagues, or you think somebody else might want to watch this webinar 4 hours after this, you can review it live with the same link. So I think that covers a bunch of questions I got about that. Also, please, track our events page on Infonetics for upcoming webinar information and the list of our calendar. You can go to the Infonetics page, and at the top, click on the Events tab. Okay, let's go back real quick. A couple more questions here. We have a couple minutes. We have a viewer from Japan who's asking about security. So the question is, what do you think about countermeasures against security threats in VoLTE? Is it the role of SBC, or is IDS IPS technology required along with the SBC? Maybe, Martin, you could take that?
Sure, yes. I mean, interestingly, of course, the 3GPP specs about VoLTE don't really say anything about security at all, apart from the authentication and authorization aspects. I think it's every network operator's expectation that the SBC is the first line of defense against various kinds of malicious activity, that the SBC will include the smarts to detect attempted denial of service attacks, whether they may be distributed or single sourced, and essentially shut down those sources of malicious traffic. To give an example here, in terms of what we're able to achieve in software, we can, in pure software, discard 500,000 packets per second based on an IP address blacklist, while still handling close to the rated, or actually at the full rated signaling load of the SBC. So yes, those functions clearly belong in the SBC, and that's the expectation, I think, of all the certainly the network operators that we've been talking to.
Mm-hmm. Okay, we have another question here. Somebody's asking about quality of service for VoLTE, and is there, do you have any?
Yeah, so QoS is handled by the LTE access network. I mentioned that in the SIP signaling flows, there are in fact additional SIP messages in there in order to handle the preconditions requirement. And essentially, what happens is that when an invite goes to or is received from a VoLTE endpoint, there is a separate negotiation that happens at the LTE radio bearer layer to establish a radio bearer that has the QoS required for voice. And once that is established, then there's this kind of a go-ahead in the SIP messaging to say, yes, okay, now you can proceed to set up the call. So the SIP signaling has to take account of it, but the QoS itself is provided by the underlying radio bearer network.
Mm-hmm. Excellent. Okay, I have time for one more question, and actually this might be a good concluding question. Somebody was asking about industry standards. If somebody wants to track the industry standards initiatives in this space, what should they watch for?
Are we talking about network functions virtualization specifically?
I believe we're talking about SBC and VoLTE in general. Are there different standards? Is there going to be specific standards to watch?
Well, it's the 3GPP standards. The thing to be aware of is that there was a big shift in the standards at the point of release 10 of the 3GPP specs, and this was around enhancing single radio voice call continuity. Those standards are very important because they give good performance now in handoff of calls from the packet domain to the circuit domain. They heavily involve the session board, the access session border controller. So that's something to be clearly aware of. But there is no single standard that says this is what the SBC must do. You have to stitch together requirements from a whole bunch of 3GPP standards in order to get the whole picture. And it's a lot of work, I'm afraid. But that's just the nature of the way those standards are put together.
Mm-hmm. Okay, excellent. Thank you, Martin. Well, that concludes our time for today, but I want to thank Martin and Metaswitch once again for sponsoring this webinar, and I want to thank Diane for her work and her research presentation. And again, if you'd like to view this on demand, it will be available in 4 hours for the next 90 days. So thanks, everybody, for participating. Hope you check back to enjoy more of our webinar series this year, and I hope everybody has a nice day. Thank you very much.